State diagrams. Hi, welcome back. We will talk now about one of the most important diagrams, the state transition diagram. State diagrams capture the different states of a software system. They provide an excellent way of modeling communications with external entities via a protocol or event-based system. State diagrams help us learn more about the effect of these interactions or the inner nature of the system. State models are not applicable for every project. Projects that need state models typically include workflow projects and projects that have data objects with much complex decision logic or business rules around them. A state diagram describes how an object behaves when encountering events with a system. The state diagram describes the effect of the external events on the behavior of a system while considering all possible states of the objects within that system. State diagrams are commonly used by software developers and embedded system engineers to visualize the entire life cycle of objects to get a better and clearer understanding of the big picture. For business applications, state diagrams can also reveal the states of business data objects and show the events that cause the objects to enter certain states. Thinking through objects in a system and their respective states can also help identify missing requirements. The good news is that the notations used in the state transitions diagrams are exactly the same as those of the activity diagram. Instead of actions, state transition diagrams consist of states. The arrows tell us the transition or event that would make the object under consideration changes states. Let's look at an example of a state transition diagram. I think it will be very easy to read this diagram. The diagram is titled State Machine Bank ATM. We start as expected from the black dot. The ATM is in the off state, while we are in that state. We can only turn on the ATM to leave the off state. As you notice, next to the turn on event or transition, there's a backslash, then startup. That means that the result of turning on the ATM is that the ATM will start up and will enter in the self-test state. What will happen inside the self-test state might be a different activity diagram. But all we know now is that we are in a self-test state. Now, two things could happen that would lead us to get out of the self-test state. Either we get a failure, in that case the ATM could be in an out-of-service state, or we gotta succeed, which will lead the ATM machine to be in the idle state. During the idle state, the machine waits for anyone to insert his card, maybe displaying a message, "Welcome to Bank ABC, please insert your card." Also, during an out-of-service state, the ATM might be displaying an error message. "Sorry, ATM is out of service. Please call 12345 for help." I guess you got the idea, and you can read the rest of the diagram yourself. State diagrams are sometimes used in conjunction with state tables. I usually begin with a state table and use it as a guide to create the state diagram. A state table has all initial states organized in the first column on the left side, and the first row at the very top of the table. The cells of a state table then show all the possible transitions and whether they are valid.